So this is a brief example from week 4. The linear model to predict the price of a used car from its mileage was fit to 27 cars, and they gave us the equation that governs it. Now, if you recall that the equation seeks to give a relationship between x, which is going to be used to forecast y, and from that we will get a graph, and the gradient of that graph is going to be b1, and the value of the intercept is going to be b0. So we are going to seek to look at how those relate to the equation that we are given, which is here. Now this would be price, and then this would be miles, and the equation is given that relates here. Now with a negative coefficient of mileage, it would be going in this direction, but this was just to recall the relationship between x and y. Now, what is an explanatory variable? Essentially, what this is, as the explanation here, it is one that is used in a relationship to explain or to predict changes in the value of another variable. So the mileage, which is the input, so you would, based on the mileage, calculate the price. The mileage would be the explanatory variable, and some people call it the independent variable, and then the price would be the dependent variable, and the response variable is the price, which is also the dependent variable. What does the slope mean? And if you look back at this equation, b1 is going to represent the slope. So b1 represents the slope, and what this means is for each increase in x, you get a corresponding increase in y, and that b1 is really equal to that ratio. So essentially it can become way more detailed, where they talk about this being the change in y and this being the change in x, and then the gradient, which is b1, by definition is equal to the change in y over the change in x. So what is this saying? If x goes up by 1 unit, then y is going to go up by b1 units. So it's really predicting a relationship between how x is varying and how y responds. Alright, so that's essentially what it is, and the equation is given right here. So what this is saying, if you notice, it's a negative coefficient. So it's saying that used car will lose on average 43.81 in the value for every 1,000 miles that is registered on the car, which is why this has a negative. So the graph would actually, for this, would not be like the one we've shown, but it would actually show that the value is decreasing, and certainly at some future mileage it continues to plummet. So it would start here when it's brand new, and then once you drive it off the lot, the price starts to decrease. So to determine the predicted price for 75,000 miles, now looking at this Excel sheet here, from the equation b0 is equal to 18,017.23 B1 is negative 0.04381, and then the mileage X, if you input it, 75,000 is unknown. Y, the forecasted Y is unknown. It's going to be here. Now that's going to be dictated by this equation, which I have captured here. So what this is calculating B4, which is my 18,000 plus value, and then you're adding that to the product of minus 0.04381, which is in cell B5, and your mileage for your dependent variable, for your independent variable, which is the miles, and then it calculates the dependent variable, and it's given a value of 14,731.48. Now the problem goes on to suggest that the predicted value is 14,731.48, but also if the price for a car was 75,000 miles on it was 16,000, what would be your residual? Your residual is going to be the difference between the actual value and the forecasted value. And if we look at the Excel sheet, this cell here calculates the difference between the actual value, which is in B11, which is what we found here. The actual value, which is what was given, minus the forecasted value, which is y hat, and this is going to be 1473.48, and the difference here is B11 minus B10. So we're looking at a difference between the forecasted value and the predicted value of 1,268.52. Alright, so this here represents the simple Excel sheet that does the calculations for you, and you would have seen the explanation. So if you have any questions, be sure to reach out to us. Alright, thank you.